Hello friends, here in this video we will see a problem based on trapezoidal channel. For that we have a question here. A trapezoidal channel section is used for closing the entrance to a dry dock, full stop. It is 16 meter wide at the top and 10 meter wide at the bottom with 6 meter depth. Find total pressure and center of pressure on the trapezoidal channel if water on the outside is just in level with the top. Now this is the question which we have. Let us try to understand this question by writing the data. So here we have, in terms of given data, a trapezoidal channel section is there and it is used for closing the entrance to a dry dock. It's 16 meter wide at the top and 10 meter wide at the bottom. So I'll draw the trapezoidal section. So here we have a trapezoidal section. It is given that the trapezoidal section is 16 meter wide at the top and 10 meter wide at the bottom with 6 meter depth. It is 6 meter deep. Next, here we have to calculate, that is find total pressure and center of pressure. So total pressure is nothing but hydrostatic force and center of pressure means H star. We have to calculate these values. If water on the outside is just in level with the top, here water is in level with the top of the trapezoidal section, it is given. So here we have the liquid as water. Now see, this is the diagram which is given, that there is a trapezoidal section which acts as if we can say that it is stopping the entrance of water, and this surface, it can be used for any kind of movement. So here a trapezoidal section is there and we have to find out that for this trapezoidal section how much force, or we can say total pressure, is exerted by water on this trapezoidal section. So for this, let us try to solve the problem. I'll write the solution here. Since total pressure is given by the formula F is equal to rho g into A into H bar. I'll call this as equation number 1. Now, since the liquid given in the question, it is water, so the density of water we know it is 1000, G is 9.81, but area and H bar, these two values we don't have, so we need to calculate area and H bar. So first I'll say that therefore area of trapezoidal section, we know that area of trapezoid, the formula is, or we can say area of the trapezium, formula is half into sum of parallel sides multiplied by height. So therefore, if we see in this problem, here what I'll do, I'll name this trapezium as A, B, C, D. So AD and BC, they are the parallel sides. So half into sum of parallel sides means it is addition of AD plus BC into height. Height is given as 6 meter into the problem. So here this is 6. So if we calculate this, half into AD is 16 plus BC is 10 into 6. So finally area comes out to be, it is 78 meters square. Now once area is known, the next thing is to calculate H bar. And what is H bar actually? It would be the location of centroid for this trapezium section. So here we would be trying to get the location of the trapezium section. So for that purpose, I will divide this trapezoidal section into two triangles and one rectangle. So here I'll call this as triangle ABM, and this would be triangle CDN. So two triangles are there and one rectangle is there. Now, in order to calculate H bar, we would use the concept of centroid. I'll say that since the location of centroid, it is given by the formula. Here we want H bar, so H bar will be equal to, here we have two triangles and one rectangle, so the formula would be A1 Y1 plus A2 Y2 plus A3 Y3 upon the total area which we have calculated. So in this, if I see area 1 is, I'll call this as the first triangle, second is the rectangle, and third is again the triangle. So now for the triangle AMB, here base would be, since this is 16 minus 10, it means this AM plus ND, that is 6. So AM is 3 meter and ND is also 3 meter. So 3 meter is the base and 6 meter is the height. So area is half into 3, that is base, into height, that is 6. Now Y1, what is Y1 actually? See, here we have this triangle and centroid for the triangle is located at 1/3 from height. Since the height is 6 meter, so centroid would be located for this triangle as 1/3 of 6. So here I have Y1 as 1/3 of 6. So this was A1 into Y1. Now for A2 into Y2, we have the second figure as the rectangle. Its width is 10 meter and height is 6 meter. So it is 10 into 6. Next Y2. Y2 is the location of centroid for the rectangle, and for the rectangle it is at exactly half of its height, that is half of 6. So Y2 is 3. This is A2 into Y2 plus now A3 into Y3. See, that would be same because on both the sides we have the dimension of the triangle as same. So here what I have written for A1 Y1, same thing would be there for A3 Y3. Half into 3 into 6 into half, 1/3 of 6, divided by the total area, and this area A we have calculated, it was 78. So from this, if we calculate H bar, it comes out to be 2.769 meter. Now this h bar is from free surface of water. Now once we know h bar, we can put all the values in equation number 1. Therefore, put all values in equation number 1. Therefore, F is equal to, rho is the density of water, density is 1000 into G is 9.81, area 78, and h bar we have calculated, it is 2.769. So from this, if I calculate my answer of F, that is the hydrostatic force, it comes out to be, it is 2.11 into 10 raised to 6 Newton. This is my first answer. That is the value of hydrostatic force exerted by water onto the trapezoidal channel. Now, after getting the hydrostatic force, I'll go for the calculation of center of pressure. Since center of pressure is given by, the formula is H star is equal to Ig upon AH bar plus H bar. I'll call this as second equation. Now I need to calculate moment of inertia for the trapezoidal section about its centroid. For that purpose, what I'll do, I'll draw that trapezoidal section again. This is the trapezium which is there. It is A, B, C, D. Now we need to calculate moment of inertia for this. So I'll divide this into 3 simple figures, that is, here we have 2 triangles and 1 rectangle. Now, since h bar is known to us, h bar is the location of centroid from the free surface of water, and that h bar value was 2.769. Since this entire height is of 6 meter, so just above the half, we have this distance as h bar. It is 2.769 meter. This h bar indicates the location of centroid, and since this is symmetric about the vertical axis, here we have the centroid. I'll call this as x axis, here we have y axis. Now we need to calculate moment of inertia for this trapezoidal section about the centroid. Here this would be the first figure for us, rectangle is the second figure, and this triangle, it is the third figure. Now I'll write down, since moment of inertia for given section, it is Ig is equal to the moment of inertia Mi of triangle AMD plus Mi of rectangle it is BMNC next plus MI, that is moment of inertia for this triangle, it is CND. It means I have to add the 3 moment of inertia. Now, as we know, we will start with the first figure, that is the first triangle. Now, since the height is 6 meter, we know that for the triangle, its centroid is located at 1/3 of height. Height is 6, so 1/3 of 6, it means at 2 meter distance, its centroid would be located. This is 2 meter distance from the base. Now, as we see here, there is difference between both the axes. We need to use parallel axis theorem here. So I'll write down, therefore I suffix g, that is moment of inertia for the section given. Now for triangle, we are applying parallel axis theorem because there is distance between both the axes, and for that parallel axis theorem, first we would be calculating moment of inertia about this centroid, and about the centroid the moment of inertia is bh cube by 36 plus area of this triangle, that is half into base am. Am is, we know it is 3 meter and height is 6, so half into 3 into 6 into h. Now h is the distance between these two axes. As we can see, this axis of the triangle and axis of this trapezoidal section. So it is 2.769 minus 2 and it is whole square. Now here what I will do, I will multiply this entire term by 2 because on both the sides we have the triangle of the same dimensions. So we can easily multiply by 2, that is we will find moment of inertia for one triangle and multiply it by 2 to get the answer of the second as well. Now after this, we are talking about the rectangle. Its horizontal axis will be at half of 6 meter, that is at 3 meter, you can say exactly at the center. At 3 meter distance, its axis would be there. So now moment of inertia we have calculated for both the triangle, that is triangle AMD and triangle CND. It is complete. Now only rectangle BMNC is left. So for this rectangle, we know that moment of inertia is given by the formula BD cube by 12, that is about the horizontal axis in black, which I have shown here. This is for the rectangle, plus its area, that is B into D, into H. Now H is the difference between these two axes. As we know, axis of the centroid of trapezium section, it is 2.769 from free surface, and from that same free surface the axis of the rectangle, it is at 3 meter distance. So it is 3 minus this value, which is 3 minus 2.769 whole square. Now here I will put the values, therefore I suffix g is equal to B is the base of the triangle, it is 3 meter on both the sides. Height h, that is 6 plus half into base into height, into this would be 0.769 whole square into 2 plus B is the width of the rectangle, and that width is given in the problem, it is 10 meters. So 10 into D is 6 meter, so BD cube by 12 plus B into D, and this is 3 minus 2.769 whole square. So from this entire thing, if I calculate I suffix g, my answer comes out to be 229.84 meter is to 4. A lot of calculations here. Now once we get the moment of inertia, I can put all values in equation number 2. So I'll show here we have equation number 2. In this I'll put all the values. Therefore put all values in equation number 2. So therefore H star is equal to Ig, the value we have calculated just now, 229.84 upon A into H bar plus H bar. Area was 78, H bar it was 2.769 plus 2.769. So from this I will get my value of H star as 3.833 meters. So this is my second answer. Now if we look into the problem, the question was to calculate the hydrostatic force, or we can say total pressure. Its value is 2.11 into 10 raised to 6 Newton. And the second part was to calculate H star. H star we have got just now. It is 3.833 meters. Once we have calculated both the values, we can say that we have completed the problem.